welcome again. I think this is mm, okay. I think I have a plan here now. Let's look at this plan. Let's assume that this is what your architect has given you. This is what he has given you. This is a drawing that you actually want to work on. Hmm? The drawing that you want to work on. I'm gonna put the I'll put this file on the comment section so you can have access to that. So you can also do the same. Let's say this is a drawing that we have and the architect sent you this. As a structural engineer now you want to place a column on it. This is a ground floor plan. This is a first floor plan. This is a second floor plan. So you can see. So the first thing that a good structural engineer would do is that you, according to our steps, you first of all you study the drawing. By studying the drawing, what are the things that you're looking at for? The first thing that I look out for in a building is this. Let's say the way I have the first ground floor. Sorry, okay, the way I have the ground floor plan, the first floor plan, and the way I also have the second floor plan, I will check if these three buildings now, these three plan, if they are the same. They are the same. What do I mean by they are the same? Like you can see now, they all have the same shape of building. You understand? Though they might not really have the same naming as the case may be, but if you look at this, they have the same shape. But one have the same shape, and that means for them to have the same shape, what we have in the ground floor might be what we are going to have in the first floor, then that is what you might also have in the second floor plan. So as this case may be now, let's look at this. Let's look at this. So let's say this type of design now, we call it a symmetrical plan. Symmetrical plan in the sense that whatever you have in the ground floor is what you have in the first floor, is what you have in the second floor. Then it's different from, let's say you want to design a duplex. A duplex at times, the building is kind of complicated. The placement of column is quite different from maybe, let's say, your school, your offices, your residential buildings, student hostels, and all. Because those ones, the column that comes from the ground, we continue to the top of the building to the last floor. So you get so, but for for a duplex, column that come from the ground floor might not go to the first floor, might not go to the second floor. That means you have to terminate at the first floor and you introduce another column in another point entirely. So that is just for that. But for now, we are looking at a symmetrical building where the ground floor plan is the same thing as the first floor and the second floor. So let's take the ground floor, analyze the ground floor. Let's see. Now I have this now. I have this. This is it. So the first thing we am going to look at for is that where are the walls that I want to work with. First of all, I will check, since I want to try my best to hide the columns. That means I will check what is the thickness of the wall. What is the thickness of the wall? That is what I will check out for. think the thickness of this wall is 225. Let's take it as 230. I'll take the thickness of the wall to be 230 because I want to use a 230 column. All right. Then the next thing I'm going to be looking at for will be which are the walls. First of all, you are supposed to place a column at every intersection line, just like we said before. You're supposed to place a column at every intersection line, just like, for instance, we have this grid 1 and grid A where it's crossing. That means I'm supposed to have a column here, and I have grid A and grid 2, supposed to have a column here. I'm having grid A and grid 3, I'm supposed to have a column at this point. I'm having grid A and grid 4, I'm supposed to have a column here, this point, intersection. This is expansion data. I will explain this. Then I'm supposed to have here, have here, have here, have here, have here. Like every intersection, look at this place where we have window here. I'm supposed to have here, like that. And so according to this, every intersection line, we're supposed to have a column. But the implication of that is, if you go by putting a column at every intersection point, it will disfigure the building, number one. It will incur, like it will put more costs on the building, which we will not like that. So because of that, we don't really mean that. So that's why we have to go by the spacing where we look at. Let's look at it again. Yeah, he said in a reinforced concrete design, there's no room for larger span due to its serviceability requirement. For that reason, 0 to 5.5 meter spacing between columns, 230 by 460 beam is recommended. Good. That means I can place a column with a spacing of 0 to 5.5 meters maximum. So let's look at now here. There's nothing here. The building did not get to this point. That means this one, I will take this one out. First of all, I'll place a column at this edge. First of all, I'll place one column here. Place one column here. Okay. Then I'll check between grid 2 to grid 3. Now, am I supposed to have a column at this point here? I will check the distance from center to center of this is 4,725. 4,725. Okay. I will now also ask myself, that means I can place a column here. I will ask myself, is there any way I can omit this grid 3 by not placing a column there? Then let me see if I can actually save money. Now I will not check between grid 2 to grid 4. Between grid 2 to grid 4 now, what is the distance? You will discover this is already going to about 9 to 10 meters. It's already going to about 9 to 10 meters. So you discover the span is too large. That means I cannot span between 2 to 4. It's too large for me to do that. That means I will have no choice than to place a column at this grid 3 here. That's for that. So there will be a column at grid 2. There will be a column at grid 3. There will also be a column at grid 4. Follow the same principle. There will be a column at grid 5 here, A5, A4, A3, A2. For now, let me put a column at grid, put a column at, I'm supposed to have column at these two places here. It's an expansion gen, but I'll come back to explain that. I just say put here, put here. Then, okay, let me ask you this question. Am I supposed to put a column at a grid 8, comma A, or grid A, comma 8? Am I supposed to have a column here? I'll check. The distance is just 2025. You can see I have not exhausted my limit. My limit is 5.5 at most. 5.5. Now I have 2025. That means I can actually combine, that means I can ignore this grade 8 now and put my column on grade 9. So if you should add 600 to 2025, you discover the value is still very small. It's not still up to 3000. So you get, so that means I will consider grade 9. But looking at grade 9 also is still very, very small. That is about 2,625. So I would also say, okay, let me check the next grade. Let me check the next grade, which is grade 10. Grade 10 is 3376. But if I should add 3375 to 2,625, you discover that the value will be approaching um, 6,000 or so. And I think it's already more than our 5.5, but at this stage, 5.5 is fine. Though there are people who can design from grade 7 to grade 10, but we will not want to do that. So from grade 7 to grade 10, we will not want to do that because the value is kind of very high. So what I will just do, I will limit my column placement to grade 7. I will omit grade 8 here. I'll put it on grade 9. Put it on grade 9, then I will also place the column on what? On grade 10. On grade 10. So another question is this: would there be need for me to place a column on grade 11 on this line here, on this grade A? Now, if you should look at this value now, it's 2250. So that if I should place a column here, it even falls inside the window here. Falls inside the window. That means I cannot even place a column because it's going to divide the window. I don't even want anything to be there. So I will, because of this window, first of all, I will consider not putting a column here first, not because of the value now, but because of the window element I have there. That one is already enough for me. So I'll consider. Then let's go by the second thought. Let's assume there's no window here. This is just like a plain wall. If this is just like a plain wall, then now I still have 2250. The value is still kind of very small. And looking at grade 12, just 1125. So if you should add this one to this, you discover you don't even have 3,500. It's not even up to 3,000. So not even up to 3,500. You discover to be better and it will be cost effective for me to ignore on this line here, for me to ignore grade 11 and put a column on grade 12. Hmm? The column on grade 12. I think on this line I'm done. I'll go to the next one. Now let's look at this. Remember there's already a column here. There's already a column here. There's already a column here. And I'm just going to do now. Actually for the next point where I can actually place a column. I would have just go for grid B and place a column here on grid B. But if I should do that, we discover there is a window element here. There's a window here. So because of that, first of all, is a no for me because there's a window here. So I cannot put a column to cut through a window. So it's a no for me. I won't do that. And the next thing, second, the second reason why I might not want to consider this by placing a column on this grid B is because 2025 is kind of close to this one here. Now our maximum value is 5.5. It's kind of very close to this. So what I will just do, I'll check out the next one. You can see even the next one is good, but on this side here, it also falls inside the window. Falls inside the window, so it's a no for me. But let's look at the value. The value would have been fine for us to combine and put a column here. So because of that, I will see of that. Though this value is not still up to 5.5, let me check out the next one. We should add this value now to this. we will discover that let's check the dimension for that. Let's check the dimension between here, grid D to grid D. I think you can see that between A to D, I have it as 6225. If you should look at this, if you are very good with design, if you are very strong, I think you can actually co-work with this. That means you can place a column here and place a column here, ignore grid C and grid D. So you get so, but that shows that at this point now, I can no longer use my normal, no longer use my normal 230 by 460 mm beam because the span of this beam is so large to the extent that the beam there might deflect at the midspan. The midspan at maybe 0.3, 0.115. Okay, so we don't want to do that. I think what I will just do, because this span is too large for me, and grid B and grid C already falls inside the window element for me. Or you can see the architect, being a wise person, uh, gave a window, gave a wall here, gave a wall here. What I will just do is that I will see if I can cut through the middle of this, um, put a grid line here at the middle of this wall. Middle of this wall, let me say, put a wall here. I see it. Put a wall here. Let's say this is a middle. Hmm? That means I will call this. Let me call this grid now. B prime. Let me call this B prime. Call it the B prime. That means I'm going to place a column here on grid 1 B prime. Hmm? Place another one here. Place another one here. You can see all my columns. I'm hiding them. Place another one here. Hmm? Place another one here. Place another one here. And see that where I placed before, because it's symmetric, I placed at number 9, but this time don't place a column on it. Will ignore 8 before, so still ignore 8. Please put one here on grid 10. Did we use that? Yeah, I think we do. Put one on 10, put one on 12. That is B prime. B prime. You can see this is B prime. This is B prime. Put one column there. Then I'll finally go ahead, and place a column on that grid D now. So you see, can I maintain on grid D now? Please remember there is a staircase here. So I'll put a column here now. Put a column here. Put a column here. 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 Staircase may be put there. Just maintain where your column has been coming from. Like, okay, I think there is another. Okay, let's just maintain this the outro. Put a column here, right? Instead of putting a column, I'll put it here. Then I'll go to my point D. Well, I will check if I can actually combine from this grid, which is grid 8 to grid 11 to 11, let me check that. Let me check the dimension drawing between grid 9. Okay, I think we still have a 6 to 5. 6 to 5. I think what I can just do here is, maybe if it's my choice, I can decide to divide this whole span now and just look for the middle, put a column there, or if I can walk through, put a column here, put a column here, and leave it. And I'll take note of this beam. This beam I can increase the depth to 600 mm. This case maybe. So also, just for the grid C only, because of this shooters that we have here, if we put our beam here, our column here rather, eh, you cannot leave this all of this place hanging. I don't like doing providing cantilever that much, because I don't like, let's say, between this to grid C, let's say I have 1,800. So I can, this is almost 2 meters. So it will be nice for me to cantilever from here to this place. Because of that, I will just place a column at grid C on this side only. I'll go again. Where did I put before? On grid 10, put a column here. Then the remaining one, I will put it on grid 9. So the C here will terminate at this point. At this point, and I think that is for that. Then stop at grid D to create this lobby. You're seeing, let me bring it so that you see it. To create this lobby, I have to create. Look at this statement very well. Where is it? Okay. Look at this. Say opening areas and prevent structural elements from disrupting intended special interaction. So it would be nice if I should not include this lobby in my stuff. So because of that, I would have just considered from grid D down to grid F before, and ignore this grid E. You understand? So, and because this grid is just 2025, so if I combine with this one, so it'll be just very nice for me to just put a column here and ignore this grid E. But because of the lobby then, I will have no choice than to also include a column here at this point, include one here, include one here, include one at this point, include one at this point, you know. Okay, this is just like a small step up. Mhm. Then put another one here. Okay, now I cannot put a column here. Cannot put a column here because there's a there's a window there. There's a window around this place here, so I can't put a column there. So remember, I already put a column here. So I will check the distance. I'll terminate my column at this point because of this lobby. Now check the distance between this to this, between grid D to grid F. Let me see if it will be nice for me to, at this point now, to ignore grid E just from this side to this place. But from here down, there will be a column on grid E. I'm going to follow that. Then draw dimension. Okay, let me check now. Grid E to F. Okay, perfect. I think the distance is 4725. Is a very nice one. That means I don't need to bother about this being deflected or something. So I can just put a column here and ignore the whole of this one and come here and just put my column here, then I'll be fine with that. Let's go. I hope you are enjoying my video. Please, if you have not subscribed, subscribe. All right. Okay, let's continue. So we already talked about this. That is grade F. So let me just complete what I'm going to do now. Let me complete this one down and finish up with this. So since I already placed a column here, place a column here, place another one here, place another one here, hmm? Place one here, place one here, place one here, place one here. I'm done with this side. Okay, let me quickly go, put a column here, put a column somewhere here, put a column somewhere at this point, then I can already put one here. I'm done for that. Okay, that means we have just this part here left. This is a very critical area that we just have to be very careful with. Okay, so before we put a column at this point E, so point F is just between point E to F is just 2,700, which is kind of very small. So let's see if we can actually combine grid G to it. So if you combine grid G, you'll be having about 3.9. 3.9. Let's do that so that you can see. Where is the dimension? Let me use linear. Okay. Okay, you can see I've just 3,900. 3,900. That means I'm going to place a column here at grid E, place another one at grid F. Then this is a staircase. What I normally do at the four corner of my staircase, I usually introduce a column. So this we have one here. This we also have another one here. Okay. Then let's look at this area critically. I would have suggest, since there's already a column here, let me see if the column can also go to this place. That means I want to span between grid 2 to grid 4. But before I can actually do that, let me check the distance. Between grid 2 to 4. Because according to our statement, I don't want to, this whole area here, you're seeing circle, very vitrified ceramic floor tile. Okay, like okay, this crutch, like the whole of this all is a crutch area, and this just like the store. So now this block actually you can actually use 150 to just. What I just want to do, I don't want to see. I want to see if I can actually help the architect or follow what the architect has done, not help. Follow what the architect has done. by leaving this whole area without having a column. So let's check between grade 2. You can see if I should put a column on grade 3 now, it's going to fall at the center of the crutch. Well, let me see if I can actually work on 4. Where is my dimension? Dimension draw linear. That will be from 2 to 4. Can see is impossible because here I have 9,450 mm. It's too large, it's not even feasible, it's not possible. So I have no choice. Let me check between grade 3, 2 to 3. Okay, this is just 4,725. So I'm gonna place a column here. I don't have any other choice because our stability is more important to us than every other thing in structural engineering. So I'm just going to place a column here at the middle of the crutch because this whole area is too large for me to leave empty. Can't span this beam so much. So place a column here. Come here. Also place a column here. But do not allow your column to fall inside your window, irrespective of what you're going to do. That means I'm done with this area now. Okay, for this area, you can see this is a glass window. This is a glass window. The glass window. That means I'm going to cantilever the whole of this area. So you can see we don't have choice. Let's see the okay. That means we are going to cantilever almost 4 meters. Almost 4 meters here. And this will cantilever what? How many? The distance 3,000. That's it's too big. It's too big. So you cantilever 3.5. Here we cantilever 3.2. Okay. I mean, there's already a column here. I'll put there's a column here, right? I'll put another one here. Then put one here. Also cantilever this side. Okay, I will not put one here. I'll put one here. And choose to adjust this one somewhere here. The middle of this one. Middle of that one. Put one there. Then put one here. But what I'm going to do here, because of this cantilever that is kind of so large of the window, I will see if I can actually double the column on this side. So double the column on this side, double the column here, double the column here. So okay, that's for that. Thank you very much. Now let's see the let's see what we have done so far. So whatever I have for the ground floor, if this one is also the same, so I'll just copy ground floor layout, first floor layout, second floor layout because they're the same. They're the same. So that's what I'm put through. Okay, then now let's see the structural layout that we have done. You can see this one I've done. This one I've done now. This is the column. Are you seeing it? The yellow color, the yellow stuff shows the column there. So all right, if you have this, just go to where you downloaded your YQARC. Go to where you have your white rack, open it this way, reinstall it, but make sure your AutoCAD is off, like your AutoCAD is not on before you do that. So open the white rack, open this white rack folder. See SYX, open it, come here, look for, don't, not this, not gsetup.exe. No, this is the one you look for, setup.exe. And sometimes you can put that and your antivirus will eat it up. So you should know what to do. So let me just click on this. I'll open it. You can see it's loading. So this will confirm file replace. Okay. Say yes to all. We would like to replace the existing file. Yes to all. Something will come up. This is a Chinese file, so don't be scared. This is it. Your AutoCAD version will come up here. Click it, and the first time you click on this one here, place my mouse, click on this, then a question mark will come up, press OK. That means you've done for the first one. Go again, click on the second setup when it bring you back to this place. Click on it. Yes to all again. Now click on your AutoCAD version for the second time. Now before you click on this, Abby. So the second time now you click on this one. Click on this. Press OK. Then I feel should have been installed by now. So I think that is all. Go back and launch your AutoCAD. Open your AutoCAD, or can even refresh if I will do that. Okay, my AutoCAD is here. My AutoCAD is here. You can see for now the YQAC is not showing here. Then the YQAC is not showing, but it's showing the menu. This is the menu here. This is the menu here. So what you're going to do, YQAC. YQ, you see a lot of stuff will come up. YQ, are you seeing it? YQ. A lot of stuff will come up. Locate YQ menu. Once you press that, you just come up here. It's loading. Some files extracted from YQ were modified or new files were created. You wish to put them to the archive. Yes. You can see something has come up here. Something has come up here, but it's still in Chinese language. But I don't want this. What I will just do, type on YQ, type YQ again. You see YQ language to change the language. I'll choose English. Press OK. Choose English and press OK. So you can see it's already showing the name YQAC. Alright, so let's go. Let's get started. Alright. So if you are done installing that and you already have this YQAC installed on your laptop, there's no problem. Let's start. So once you're done, according to this value that we got, I will say, on this grid one, now we are definitely going to place a column here. That means in my structural layout, I will definitely capture this grid one. Then there's a column here. Please capture this grid 2, 3, 4, 5, 6, and 7. Grid 8 now, there's no column here, right? But if you check, there's a column on grid 8 here. So definitely I'll capture grid 8. And there's a value for grid 9, grid 10, right? Grade 11 and grade 12. So what I'm just going to do is I'll write out the value between one spacing, between one grid to another, the grid that you know that there will be a column, even if at all, it's going to be just one single column that will appear there on that grid. You still have to capture that grid line in your structural drawing. So there's spacing between grid 1 to 2 is 3 to 5. Between 2 to 3 is 4725, between 3 to 4 is 4725, and so on up to this point. So let's go. This one now you move from left to right. So let's check out the what we have here. We have 3225, 4725, and so on, and get so up to this point. That is for that. Let's go for the height. This from here, from here now. This is from bottom to top. From here up, from bottom to top, 4725. Because do you know why I'm putting this grid high now? Because on this part there's a column. Definitely I'll capture that 4725, 3525, 1200 up to, I think that I captured this. Yeah, so there's a column there. So I'm gonna have all of that. Then once you do that, the next thing you will do, go straight. Let's check out this value also. You can see it for the height 4725 up to 3075. So let's go back to AutoCAD. Now we want to reproduce this. Now I'm using YQAC to reproduce this. Don't worry, I'm going to make a video on how to use Orion to also do something similar. For now, this is just YQAC is a plugin to your AutoCAD that we are going to use. So for now, let's go to the YQAC. Click on it. You see plain wall and column. You see grid, draw grid axis, or you can enter a command ZXW. Let me click on this to automatically take me to somewhere, because I've done this before. The value is still there. Value is still there. But you can choose to clear everything up and put your own value afresh. Let's say this is 3225. Now for you to separate one spacing from another, just use your space bar. Use your space bar to separate it. Your space bar to separate it, and this is what I have. So I'll go. You are done putting your value. This is the breadth is from left to right, and this depth is from bottom to top. Just click OK, and you see that come up. See it here. I just press OK and put it here to automatically generate the axis, the dimension, and everything I have. You can see this is very fast and very, very accurate. You get very, very fast and accurate. Fast and accurate. So that's for that. Now you can see the dimension, you can see the depth, and everything is fine, well placed. So the next thing I want to teach you here is how to also place your column. So let's go. So column, let's go, come back to this place. Plain wall also. You see arrange columns. You can also type in ZZBZ. Add column. Now it's asking you first corner or change. Let's come to this place. First corner or change. Default angle, size, diameter, filling state. So the first thing is I want to indicate the size of the column. So let me say press S. Are you seeing this S here? It's S, have you? That's what I type, then press enter. The next thing you'll be seeing is input size of the column, width and height. So let me go 230 by 230 that we're using. So press OK. Then the next thing it should be showing is then you need to ask yourself, will your column be shaded or it should just be empty? This is what I mean by shaded. Let's go. This is what I mean by shaded. Let's look at this one I've done before. You can see yes, fill, like yes, fill. Yes, fill. If you look at this one, this foundation, you can see this one is not shaded, Abby. This one is kind of empty. So let's go. That's what I mean by that. You see it now. So if you have done that, click on this filling state. You can see filling columns automatically. Yes. Y stand for yes, and N stand for no. For now, I want to fill in the column, so I will leave it like this. I'll press enter. So the next thing I will do, I will highlight everywhere I want to put a column. Automatically, columns will come up on that. Please, if you have not subscribed to this channel, try your best to subscribe so that you can see my subsequent videos on reinforced concrete design, on steel design. If you follow this channel, you will learn a lot. You learn a lot, promise you. Okay. All right, that is for that. That's for that. You can see I've been able to put in the column. But I think there are some places that I don't actually want to put column. Let's say this side, this side, this side. I don't need columns there. What I would do for you to remove the column that you don't want at all, like this one and this, press EW, press enter. You understand? Let me click this. I will say select object. I've done that already. You can see they've gone. This out. You have to remove the columns you don't want. EW. And then I think I can also do the same here. I think from here I don't need this column. This column here. EW also. Then I will light from here. I guess so. Don't need them, so I will press enter. You go off. You can see those are the ways to remove your columns. There's a way to remove a column. Then the next thing I would love to teach you. Okay, you can see that this is very, very fast. So put column wherever you want to put a column. And the next thing I want to teach you now is how you can put your wall. Let's say I want to put a wall, this is just a grid line center to center. Just come to my YQ arc here. Plain wall and column. I come to as this line towards this line towards, can also press XWW. So let's have that. It is asking you to choose the thickness of your wall. Here I have 230 mm. Press that. Press that. Just click on select the object here. Just select this. Select this. Select this. Select any wall that you want to put, any grid line where you want to put that. Do that. Okay. Then the next thing I will do, I'll press enter. You see the wall come up on all the axes that I've already choose. You understand? This is very, very simple. So I'm going to be giving you a task to do. I'm going to be giving you a task to do. Let me just put all of them. All of them. You can decide to highlight everything once. Decide to highlight everything once. If you are in final year or you are in 300 level University of Benin or any university at all, you can make use of this video and it will be very helpful for you, or you are practicing and you want to be doing your structural design yourself. my video will be of great help. You can see that this is a end product of where we are going. So I will leave you to produce this yourself exactly the way I've done it. This one may have done. Then another way to change the color of this, if you don't like what you have here, let me say you can see the wall is already placed. The column, some areas has a column. Let me just change the column alone. See, I just click on the column alone. I want to change the color. I'll right click. I'll right click. Oh, okay. I'll right click, similar. Select similar. I selected similar, then I will go to properties and change the color to my desired color that I want. My desired color. You can see I have the color here. To choose yellow. I think I'm fine with that. I love that so much. You can also choose red. You can see all the columns has changed to yellow color. Then if you also want to change anything, let's say this grid line, to change it to maybe another color entirely. Also click on it, right click, select similar, go to properties, change the color to any color of your choice. You say okay, don't want white, change it to like that red. Let me change it to this. You can see I've been able to change that. Then you cannot leave your grid line like this. Your grid line has to align with what is in the architectural plan. Let's say for instance now, this one now, what do you have here? You go back and check. Go back to your drawing and check what you're doing and check. At this point now, I think we have I that is here. So for your design not to be worthless, you have to maintain the grid, pay attention to every single details. Yet, so for instance now, this is what I'm working on. We just come here. Just grid A is grid I. Come here, change it that. I mean, I have a lot of stuff on my laptop, so come here, change it to I. You can see that. Change this to I. Hmm? This is let's check what is there. Check what we have there. I think we have H. Okay, we have H there. H there. We have H there. So that is how you continue to change that. Then at the end of the day, you trim some parts that you don't need. Trim them up. Just like for instance now, this part I don't think we actually need. this part here. And so trim this one off. Trim. Select again. Trim. Take this back. It. Click on this. Back a bit because I don't have anything there. See this. See that? Can decide to take this grid back to this place here. Seen it? So I'm trying to clear this area to tell you that let's this one join this. Let's flat. Take this one back. Okay, you can see we have done this now. It's very neat. Very, very neat. You see, very, very neat. You get so that is how to do it. Please, I would love if you can come back to this place and do it exactly like this. Put this video in the comment section or in the link. Please try your best and see you once again. I'll still do more video on how to do complete structural layouts. So this video will not be too long. Thank you for watching.